Hi everyone. Next we are moving to the chapter number 4, tuning circuit and filters. So from this is from UNIT-2 chapter number 4. So the first concept here, what is mean by tuning circuit? Tuning circuit is nothing but the process of selecting desired frequency is called as tuning. What is mean by tuning? The process of selecting the desired frequency is called tuning. Okay, so how this will happen, how to select the frequency, we'll discuss in this particular chapter. Any circuit parameters, it is a circuit whose parameters can be vary. The parameters may be resistor, inductor or capacitor. You may vary. You can make it to the frequency level up to the resonance frequency. That means that the frequency, whatever the frequency you want to make it as a resonance frequency, we can vary the parameters of the circuit. That's what here I'm going to tell you. So in case, here two circuits we have. Those circuits are RLC circuit and RL parallel circuit. It is a series circuit as well as parallel circuit. What exactly it is? See, for example, TV as well as radios we have. So how it is possible to make particular channel you can available at the TV particular tuning frequency? How it is possible? See here. In case of tuning circuit, we tune the frequency desired level that match with the carrier frequency in that particular channel. That means that this particular frequency we can select with the help of this tuning circuit. This tuning circuit, with the help of the tuning circuit only, we are making the channel, which channel you want, we can resonate that frequency into the channel frequency. Then our TV channel going to be adjusted. Similarly, radio also. In the radio, if you want to listen some particular channel, for example, uh, 93.7 FM or radio FM radios are there. How to can you tune that? We can tune our frequency match with the 92.7 FM frequency, then you can listen the songs. So that is a process of tuning. I hope that everyone is clear about that. Now we are going to tuned circuit. What is mean by tune? Just now I mentioned. What is mean by tuned circuit? Tuned circuit, it is a circuit. Yes, it is a circuit whose parameters have values that will make it resonant to a particular frequency. That is called as a tuning circuit. Got my point? That means that we can adjust the parameters to resonate the particular frequency as a resonance frequency. That is a tuned circuit. So we'll see the characteristics of tuned circuit. We are going to discuss three important characteristics of tuned circuit. The first characteristic is to select desired signal, to select the desired signal out of the many available signals. Okay, got my point. So what is mean to the first characteristics? We have so many signals are there. We can select the particular signal. What signal you want, you can select it. Okay, that is first characteristics of tuned circuit. This particular characteristics you are calling it as a sensitivity. Okay, sensitivity. Next, second characteristics, to reject all undesired frequency, to reject all undesired desired signals. Okay, so this is called as a selectivity. This is called as a selectivity, the characteristics. Third characteristics is the increase the value voltage of desired signal before passing to the next level. Increase the value of desired signal, desired voltage connected to passing to next level. Okay, this is called as a fidelity. So in the examination point of view, why you are studying all these three characteristics, they will ask the question is like that. These are the following characteristics of a tuning circuit: selectivity, sensitivity, fidelity, all of the above. Which option is correct? All of the above. Fidelity is there, selectivity is there, sensitivity is there. Okay. Next we are moving to the resonance. So we are taking two type of circuit. One is a LC and then LC series, LC parallel. You know, this is a LC, it is called as an oscillator. Is like oscillations. We will discuss in this particular oscillator topic in detail. But now we can listen what exactly this particular circuit will be do that. So resonance. In this particular case, you know, in the series circuit, ideally there is no internal resistance of a inductor as well as internal resistance of a capacitor. It means that the leakage current in the capacitor will be 0. Okay. Now at a resonance condition, you know that inductive reactance is equal to capacitive reactance. Whenever both are equal, you know, XL is equal to 2 pi FL, XC is equal to 1 by 2 pi FC. From that, F0, that is a resonance frequency, that 0 indicated that the resonance frequency is equal to F0 is equal to 2 pi root LC. That already discussed in the previous chapter or series AC circuits. But once again we will recall all these. So from that, you know, this particular condition I0 is equal to V by X. So at resonance condition, you know, X is equal to XL minus XC. At resonance, you know, XL is equal to XC, that will be 0 here. So 1 by 0 infinity. That means at resonance condition, there is no internal resistances of capacitor and inductor. The current offered by the circuit is infinity. So current circuit offered by the infinity is means that it is a very high current. It is a theoretically it is possible, but practically, you know, some small resistance will be present internally. So the current will be very high value in that particular cases. Okay. So coming to the, you know, in case of parallel circuit, second circuit. So in the second circuit, what is the beauty of the second circuit is both are connected in parallel out of phase 180 degrees. First of all, we are giving some supply initially. If we are disconnecting the supply also, this trying to discharge this energy to the capacitor, and the capacitor again charging and discharging energy to the inductor. This keep on increasing, oscillations are produced. This is an oscillator circuit, LC oscillator circuit. Okay. So in that particular case, you know, the current, once your oscillations are done, gradually the current I0 will be 0 in this particular second figure, in this particular case. So whenever I0 is equal to 0, what about the impedance? V divided by I0, that will be V divided by 0, it is infinity. The circuit impedance is infinity, offered by the circuit impedance is infinity in this particular LC circuit. Okay, this is about the resonance. Okay, so what is the actually resonance, series resonance? In the actual series resonance, you know, resistance is also included in the circuit. So this is a phasor diagram for series circuit. In that, what impedance will be R plus JXL. everything, jxl minus xc based on the which value is more. In this particular case, I am taking the xl is more value compared to xc. So in this particular case, xl is equal to xc, finally z is equal to r. At the case of resonance frequency 1 by 2 pi root LC. So what are the things I am repeated in the same chapter in the AC circuit, but here also repeated the same thing. So we are going to discuss about the two parameters, then we will end up this particular resonance circuit lecture 1. In the lecture number 2, we are going to discuss about the parallel resonance as well as coupled circuits, after that filters. Okay, Q value. Q is nothing but a quality factor. It is a quality factor, is also called as a figure of merit. It is also called as a figure of merit. Okay, the quality factor is defined as, it is a ratio of inductive reactance divided by R. Or capacitor reactance is divided by R. Both are okay. XL is equal to omega naught L by R. This is a formula, omega naught is equal to 2 pi F naught into L by R. This is a formula for quality factor, already you know that. So this quality factor, for example, resistance is equal to 0. What about the quality factor omega naught L by 0? That is a quality factor is infinity. Theoretically it is possible, practically it is not possible. The quality factor is infinity. Even though very high value of frequencies, the resistance will be more because of skin effect. Yeah, the skin effect. In the previous chapter I explained that due to the skin effect, outer the current will be flowing the surface of the conductor, the area utilized by the particular current is reduced. That means that resistance will be increases. Whenever this resistance increases, quality factor decreases. So that's what here, very high frequencies also, even though quality factor is reduced because of skin effect. So this is about the quality factor case. Next, in case the quality factor in case of capacitor case, how to define the quality factor? Quality factor is equal to, it is a ratio of capacitor reactance divided by R. What is the formula for capacitor reactance? 1 by omega naught CR. That will be equivalent to 1 by R root L by C is a formula for quality factor. That will be equivalent to, quality factor is equivalent to F naught divided by F2 minus F1. That is a F naught divided by delta F. This is about the quality factor in case of capacitor case. Is it okay? Next, we are moving to the bandwidth. So the quality factor, the bandwidth here, the upper cutoff frequency, the difference between the upper cutoff frequency minus lower cutoff frequency, that will be the F naught divided by Q naught. That will be equivalent to R by 2 pi L. That is a bandwidth. So the bandwidth, the main while you are observing this particular equation, the bandwidth is not depending upon the capacitor. Very, very important. Bandwidth is not depending upon the capacitor. So independent about the capacitor, bandwidth. The bandwidth is depending upon the resistance as well as inductance. Okay. But even though, coming to the next one, LC product. In case of LC product, resonance frequency F naught is equal to 1 by 2 pi root LC. So the product of L and C varies. The product and L and C are various. We can change the frequency of resonance frequency. That concept only you using, you need to make it the resonance frequency, desired frequency. So maybe if you are, as well as you are maintaining L and C product is constant, even the change in inductor, the change in capacitor in the ratio, the product will be constant. If you are maintaining, the resonance frequency is maintained the constant. That means you want to see the particular channel in the TV, you need to stabilize the frequency. Otherwise, the picture will be going to be blinking. That's what here the resonance frequency. After selecting the resonance frequency, you want to stabilize the frequency level. So you should keep it, L and C should be constant. So this is about the resonance frequency. of series circuit. Okay, thank you.